All right, so we are moving on to a geometry unit, and we are on page 584. Today I'm going to talk about some of the formulas that we've used to find area in the past. I'm going to do a couple of examples, and then I will give you some practice problems to do on your own. So, like I said, I'm on page 584. You can see that I wrote in some numbers in there, and that's just so that we can use them for practice problems. If you want to pause the video and write in those numbers, please do so. All right, so the first one, we have a rectangle. And if you remember, to find the area of a rectangle, you do length times width, or you could call it base times height, same thing. So my length is 8 times my width is 4. So the area is 32, and since I'm labeling it inches, squared. Area is always labeled in squared units. All right, down for the triangle. To find the area of a triangle, you use half of height times base. Okay, so the base of my triangle is down here. It makes a flat line. And then the height of it, remember, is going to be that 90-degree angle with your base. So I would do 1/2 of my height, which is 8, times my base, which is 6. So I don't actually use that 9. So I would do 8 times 6 first, which is 48, times 1/2. Or in other words, 48 divided by 2 is 24. And I would label it centimeters squared. Down there in the bottom, you have a parallelogram. A parallelogram has 2 pairs of parallel sides. So for our area formula, we use base times height. It's very similar to a rectangle, except for the sides are slanted. So my base is this 9 times my height, remember, makes a 90-degree angle with the base, so that would be 7. So this time I don't use the 8 there. So 9 times 7 is 63, and I would say 63 meters squared. All right, so now we have a trapezoid. The trapezoid formula is probably the longest formula that we use. And we have the area equals 1/2 of height times base 1 plus base 2. So if you remember what that means, our base 1 is one of the flat sides, and our base 2 is the other, so they are parallel to each other. And then our height, again, makes a 90-degree angle with our bases. So now I can just substitute that in. Let's say 1/2 of my height is 7, times base 1 is 10, plus base 2 is 11. So I don't actually use that 8 there. I don't use the slanted sides. So I would use PEMDAS to solve. So 10 plus 11 is 21. I'm actually going to show my work backwards. Then I would do 7 times 21 is 147. And I take that times 1/2, or in other words, divide it by 2, and I get an area of 73 5/10. I would label it miles squared. So that one has a few extra steps to it, but always remember that your bases are going to be parallel to each other, and then your height has to make a 90-degree angle. All right, last one, we have a circle. The area of our circle is pi r squared, where r stands for the radius. Last year we talked about diameter and radius. The diameter goes clear across the center of a circle from one end to the other. The radius is only half. So, looking at that circle that I'm given clear across the circle, so I'm given the diameter. So the radius to find the radius, I would need to figure out what half of that diameter is. So I would take 10 divided by 2 to get my radius, which is 5. So my radius equals 5. Now I substitute that into my formula. Pi times my radius, which is 5 squared. 5 times 5 is 25. And then I take that times pi, which we're going to use 3.14. So 25 times 3.14 gives me 78 and 5/10 millimeters squared. So that one's a little confusing because I wasn't given the radius to start with. When you are given the diameter, you have to divide it by 2 to find your radius in order to use the area formula. When you're given the radius, you can just plug it in. All right, so your assignment is actually to skip over to page 586, and you are going to do numbers 1 through 9. If you need to look up at example 1 and 2, please do so.